then we laser cut all of them. An apartment event.
Okay. All right. So basically, the remainder of the time you can ask me whatever questions you have trouble with on the homework or in the review. Then we can go over it. The answers to the quiz are already on my website, by the way, the one you just took. So.
Yeah, we should put it on the website.
I just put it after I, just before I said, all right, time's up. I activated it.
Is the exam cover Bernoulli equations?
No. So it's just going to be the obvious stuff like from chapter 3, basically what you saw on the past finals. So I'm going to ask you to solve different kinds of second order differential equations, both homogeneous and non-homogeneous. Sometimes you're going to use undetermined coefficients. You'll need to know variation of parameters. You of course need to know the spring problems. You need to know Abel's theorem. You also need to know just those proof questions. There are a couple of them on the past finals. One of them asked you to prove Abel's theorem. Some of them also ask you to prove that given any initial conditions, you'll be able to find a solution that satisfies them, things like that. But yeah, I don't plan on throwing any curveballs. So basically, if you went through the review and the homework, you should be solid. Yeah. Okay.
Fall 2005.
Fall 2005.
4.
Problem 4. B. All right.
The question is the second derivative of y minus 4 first derivative of y plus 4y
Plus 4y.
equals 3. And the initial conditions are y 0, 0.
This is 1. Okay. Let me write that below. Right?
Yeah.
Okay, that's the question, right? Okay. All right, how do you start?
We first find the homogeneous.
All right, how do we do that?
We set the
What's the equation?
Y r squared minus 4r plus 4 equals 0.
Okay, can we solve that?
Yeah, we can factor it. It's r minus 2 squared equals 0, and you have r equals 2.
Right, so we have a repeated root here of 2, right? Which means our homogeneous solution looks like what? Okay, so now that we have that, we can choose our particular solution because we want it to look like this, but not like that. But these exponentials obviously don't look like a constant, so we're nice. And so what would I guess the solution looks like? Just A. So which means yp prime is the same as yp double prime, which they'll both be 0. And so then I will plug these into the differential equation. I'll get 0 minus 0 plus 4a is equal to 3, which means my a is equal to 3 over 4, which means my general solution is c1 e to the 2t plus c2t e to the 2t plus 3 over 4. And now since they gave us initial conditions, it means they want us to find the C1 and C2. So then we're going to need to differentiate. And that gives us 2C1 e to the 2t. This one we'll need the product rule. Differentiate the t first. Then differentiate the exponential. The rate of the constant is 0. So now we can plug in. So we know y of 0 equals 0, which is equal to, I just plug in 0 for t here. And so that will be c1 plus c2 plus 3 over 4. And y prime of 0 is equal to 1. So I plug in 0 for t here. So that would be 2c1 plus c2, and the t here is 0, so that is it.
Shouldn't be sensible from y to 0.
Something
Should
there?
be 0.
Y 0 to 0. There shouldn't be a
There's no
C2.
C2.
Yes, there is a t. That is correct. Good. So from this we know that c1 is just minus 3 over 4, which implies that we have 1 is equal to minus 3 over 2 plus c2, which means c2 is equal to 1 plus 3 over 2, which is 5 over 2. This means we have the general solution is c1 minus 3 over 4 e to the 2t plus c2 5 over 2. That's less t e to the 2t plus 3. Questions? Other one.
It's from fall 2005, number 9.
Yes.
The question is y double prime minus 4y prime plus 4y equals e to the 2x over x.
Over x.
Yeah.
Okay. So it starts out innocently enough, it's pretty much the same as this guy. So we know that the homogeneous solution is going to be c1 e to the 2t plus c2t e to the 2t, well, x. We're using x here. Okay, so what does our yp look like?
Negative y1.
I think we have to use various parameters for this.
Right. You can't just say this because this doesn't fall into category of any one of the forms. It is not a polynomial times an exponential. Therefore, we cannot use undetermined coefficients. We will have to use variation of parameters. E to the 2x over x is not a convenient form for undetermined coefficients. So yes, you have to know what forms work for undetermined coefficients. There are times when a final exam will tell you what method they want you to use, but I won't. I'm just going to give you an equation. You have to figure out, I need undetermined coefficients, or I need variation of parameters, or I need something else. All right, so you should recognize that undetermined coefficients cannot work with that. So now we're going to jump into variation of parameters. What do we need? We need the Wronskian, right? So we are going to call one of these guys, let's say the e to the 2x, I'm going to call that my y1. X e to the 2x, I'm going to call that my y2. And now we're going to compute the Wronskian. This is e to the 2x, its derivative is 2e to the 2x. At x e to the 2x, its derivative is e to the 2x plus 2x e to the 2x. So this times that, I get e to the 4x plus 2x e to the 4x minus 2x e to the 4x. These guys cancel each other, so the Wronskian is just e to the 4x, which is it's very typical, that sort of thing. You can learn that form if you want. And so our particular solution would look like what? What's the formula?
Minus 1
minus y1
instead of g y2
G times y2
over 1
over the Wronskian.
plus y2 instead of g y1.
Alright. So yp is equal to minus y1. My y1 is e to the 2x times the integral of g.
Which is e to the 2x.
So this is e to the 2x over x times y2, which is just x e to the 2x, all over the Wronskian, which is e to the 4x. Right. Technically, this isn't a dx. We ignore the arbitrary constant, but we can be informal here. So this is x e to the 2x times the integral of e to the 2x over x times
E to the 2.
e to the 2x all over e to the 4x. So here, the x's cancel. These times each other is an e to the 4x divided by e to the 4x. So this is really just minus e to the 2x times integral of 1 plus x e to the 2x times, here, these guys cancel. So this is just the integral over x. So this is minus, this is just x, so this becomes x e to the 2x plus x e to the 2x ln x. And now, what do we notice? This guy is actually similar to the homogeneous solution. So you essentially ignore him because it's redundant. This means, the question asks for the general solution, I assume? So this means the general solution y is equal to c1 e to the 2x plus c2x e to the 2x plus x e to the 2x ln. Questions on this? Any questions on what happened? Yeah.
When I asked for the particular solution,
The particular solution would just be this guy.
so you ignore the other part?
Yeah. Because it looks like the homogeneous solution. So it's redundant. You just throw them. Yes.
Hey, would it be mathematically incorrect to include the constants inside functions and they cancel out?
Well, you don't know if the constant from this is the same as the constant from that, in theory.
So I'm saying, but like over there, you use C1, so you say, let's say y1 equals C1 times e to 2x. You say y2 equals C2 times x times e to 2x, and then when you take your Wronskian, it all cancels out.
See, no, you take the function parts. I don't think it would all cancel out with C's. But it won't really matter, because you'll get a constant factor here. All the constants would not cancel out, but you'll have a constant factor here. And then what you do is you essentially ignore them anyway. So, yeah, just take the parts after the C's for the function. Other questions? Yes.
Can I ask a question out of the final, like from the book?
I'm sure.
Okay. It's from 3.4.
This is a problem similar to a homework, I assume?
Yeah.
Okay, so... All right, so what was the question?
So it's double second derivative of
X, y double prime? Okay.
minus 4 prime plus 4x cubed
Plus 4x cubed.
is equal to 0. And y1 is equal to sine x squared.
Sine of x squared. Okay. So what was the question?
To solve, find the y.
Find the second solution. Okay. So how do we do this one? Reduction of order, right? So whenever they give you a differential equation, they tell you one of the solutions and they ask you to find the other one that's linear independent. It's reduction of order. Yes, that's also on the test, I forgot to mention. All right, I did mention it before. It's on the review. That reduction of order is included.
There's one of the notes.
Yeah. So, reduction of order, how does that work? Right, you assume that y2 is just a function times y1, right? This is a function of t, remember that. It's not a constant. obviously, if there was a constant, that would be redundant. So this means we assume that y2 is equal to v times sine x squared. And so now we're going to want to plug it back into this differential equation and sort of figure out what that v is. And so we have to find y2 prime, which is just v prime times sine x squared plus 2x v cosine x squared. And then we have to find y2 double prime, which is v double prime sine x squared plus 2x v prime cosine x squared plus, this one's going to be nasty. Right, it's a triple product rule, right? There are three functions here. Right. Remember, v is a function of x. So we do the product rule. Remember, each function gets to be the derivative of 1. So in the first case, I differentiate the 2x. I get 2. In the second case, I differentiate the v. I get 2x v prime. And in the last case, I differentiate the cosine, which I would get minus 4x squared v sine. And so we plug this into the differential equation. Can I simplify anything here? Combine anything? No? These two, right?
Can't see the finger.
Yes.
Yeah, so instead of writing these, I'll just write plus 4xv prime cosine x squared. Can I simplify anything?
Do we benefit from factoring out something at all? Potentially?
No, not really. Just combining stuff so we have less stuff to write down. That's usually the best. So we have x times the y double prime, so we're going to take all of this and we're going to multiply it by x. So we would have v double prime x sine x squared plus 4x squared v prime cosine minus 4x cubed v sine x squared.
Plus
That's our
2v
okay
x.
2vx cosine x squared.
plus 2v cosine x squared. This would be times x. Okay, so 1, 2, 3, 4, 1, 2, 3, 4. All right, now we're going to do minus the first derivative, minus v prime sine x squared minus 2xv cosine x squared. Then we're going to take 4x cubed times the y. So this would be plus 4x cubed v sine x squared. All of that equal to 0. Does anyone die? Someone should.
Harsh.
Yeah, the 4x cubed.
These guys?
Okay.
Gone. Anyone else?
On the
2x
yeah.
v.
These guys? Gone.
Yeah.
That's all we can get away with, right? So here we have v double prime x sine x squared plus 4x squared v prime cosine x squared minus v prime sine x squared. So now what's the trick? Now we can reduce the order, right? You can do a substitution. U equals v prime. So u prime would be v double prime. So set u equals v prime. And then what happens is this becomes u prime x sine x squared plus 4x squared u cosine x squared minus u sine x squared, which is now a first order differential equation. That's why it's called reduction of order. We went from a second order to a first order. Now we have to remember how to solve first order differential equations. How do we solve that one? What kind of equation is it?
Separate.
It is separable. That took way too long.
It's
U prime x sine x squared. Right? I can bring over these two guys on the other side and factor out a u. Right? This is u times sine x squared minus 4x squared cosine x squared. So this pretty much means I have du over u is equal to sine x squared minus 4x squared cosine x squared dx over x sine x squared. Did I copy everything down correctly? We have x sine x squared, and I brought the u over, so I have sine x squared then I have that 4x squared cosine x squared. I think we're good, right? So now we have to integrate. So we're going to integrate both sides. Basically, this one here is going to be ln of u. This side here would be the integral of, just split the integral into two, right? So this is 1 over x minus 4x cosine cotangent x squared dx. So this is going to be ln x minus integral of 4x cotangent x squared dx. How do we deal with that guy?
Part by parts integration.
No, substitution. Right. First, you do a u equals x squared, right, to write this simpler. Right. And so this will actually give us ln x minus, this would be 2x 2 cotangent u. Anyone remember the integral of cotangent? It's another ln, right? ln of, I think it's cosecant minus cotangent. Is it? Like that one I don't remember. We can check it though. Right? If we differentiate ln of cosecant minus cotangent, that's our y. The derivative would be what? 1 over this, cosecant u minus cotangent u times the derivative of this. What's the derivative of cosecant? Minus cosecant cotangent minus derivative of cotangent. Derivative of cotangent. It's what? ln of what? Negative cosecant. Are you sure?
Want to Google it, someone?
Negative cosecant squared.
Someone Google it. Yeah, someone just Google it. Even if he doesn't know, but just Google it. I expected the math was to know.
Yes. It's what?
It's negative secant squared.
It's not secant. It's
Cosecant squared.
Cosecant. I mean, sorry.
Okay. And so if this guy, what you'd realize, you can factor out a cotangent. Well, you can factor out, what do we factor out? You can factor out a cosecant and we get cosecant. That's not. What do we have? You see, we have cotangent. What are you guys talking about?
He's like,
Why
you
not
kids,
even listening?
he's like, you kids are stupid. He's probably thinking like.
Yes.
Originally, you don't do the cosine of sine equals cotangent and leave it as 4x cosine x squared over sine.
Yeah, because to do that you do a u substitution.
Yeah, I'm just pulling out the
Like you
Google.
can do
I'm pulling out Google
sine
out
x
here.
squared,
Okay, you got this.
and then times 2 at the yeah.
Right? Now it's supposed to be a minus, right?
Yeah, so it change to
Well, this was the minuses. So plus c. How do we combine that? How do we combine that? So basically we have ln of u is equal to, we can write this side as a big ln, right? Ln of a times x times,
Is it supposed to be sorry, x to the power 4? Like, why are you going directly from a to x squared?
well, it will be ln of sine u.
U squared, right?
No, the u is not
Oh,
squared. It would just be ln of sine u, but my u is x squared. I did it. Okay, so this is
It's gonna be on the test.
times sine x squared raised to the minus 2. So this means our u is equal to ax sine x squared minus 2. This means our u equals b prime ax over sine x squared squared. This means that b is equal to, how do we do with this one?
My God, what is this?
We need another u sub. Probably using u sub wasn't a bad case, but we're using u for something else.
Professor, I just checked. The term of cotangent is just sine.
What?
And this u is x squared.
Yeah.
That's very good.
Okay, so what else do we have? So this just becomes minus 1/2 a over u. Tell me we shouldn't be doing a u sub, it should be like a t substitution because u is already on this side. Whatever.
Was this a final problem?
No, she took a random problem out of the book.
No, those guys
She
are
wants to
crazy.
challenge herself.
These guys are
It was
crazy.
in the homework. Why would you give such?
What? This is
No,
what?
it wasn't.
It was.
He's like thinking, please, this is easy for him.
U is. Oh, sorry. This was. I did u equals. Just a big sign. I did u was the whole sign. So this is just integral of a times squared. Squared is 1/2. So b is equal to 1/2 tangent. Equal to 1/2 a tangent the original was what? Y1 was what? The sine x squared? You're gonna put this as problem 1.
Yo, I'll throw a test at you. I'll beat you with that camera if you do.
Yeah, this one took us way back. Okay.
My God.
That was a fun exercise in patience.
Yeah. And then you guys are getting off. Oh, it's ln of cosecant.
What is this? This must have found this in Roswell or something, right? I mean, was it crack open the spaceship? They were like, what is this?
We have very little time. Is there a last question?
Oh my God.
From homework, it says a mass that weighs 8 pounds stretches a spring 6 inches.
So we have a mass that weighs 8 pounds, stretches 6 inches. I'm going to use feet.
And there's an external force of
8 sine
8t.
8t.
And then let's say if the mass is pulled down 3 inches, then release.
The mass is pulled down 3 inches, then released.
Determine the position of the mass of n times t.
Okay, so we're going to need the m, the gamma, and the u, right? So m is
8 over 30.
weight over gravity, right? So it's 8 over 32, right?
So
Right, which is 1 over 4. Gamma, they didn't mention any damping from what you read, so gamma is
So
0.
gamma is 0.
And k would be F over L. The force is 8. L is a half, so that's 16. So in other words, our differential equation would be a quarter u double prime plus 16u is equal to 8 sine 8t. With these initial conditions.
We didn't talk about that.
No, we didn't talk about that. I'm not putting that on the test. I'm not giving you an external force on the test. This side I'm going to make 0.
Why the initial condition is 0, 0 equals 1.4, right?
He said it was stretched down by 3 inches, right? 3 inches is 3 over 12 feet.
Oh, yeah.
Right, I have to convert to feet. My units are all in feet. So 3 inches, I have 3 over 12 feet. Right. Which, I feel like I would have tricked some of you with that on the quiz.
Yes, you did.
Where I said it's contracted up by 1 inch.
1 inch or 2?
Well, there are different versions, right? One was 1 inch, one was 2 inches. Right, so you guys had to remember to divide that by 12. So you wouldn't, the initial condition wouldn't be -1, it'd be -1 over 12.
I got that shit.
So just so you know, it's very important to pay attention to your units. What?
I got it earlier.
Yeah, this you would use undetermined coefficients because this is a nice value. So, yeah.
Just to be sure,
this
that
will
one
be
with the
solved.
external force is not on the test.
Undetermined coefficients. Right, I'm only testing up to 3.7 on the test, so this side will always be 0. I'm not going to give you a non-homogeneous case here.
Yeah, I have a similar spring problem that I want to go bit.
I would assume if I just set these up, you guys can finish them off, I guess.
It's from spring 2005, 10B.
Alright, settle down. What does it say?
A mass weighing 2 pounds stretches a string 6 inches. A spring 6 inches.
Weight is 2 pounds. It stretches a spring 6 inches.
Yeah. The mass is pulled down 3 inches and given an upward velocity of 1 foot per second. Find ut, the displacement of the mass in feet from its equilibrium position at time t seconds after release. Assume that the acceleration due to gravity is 32 foot per second squared and that air resistance is negligible.
Okay, so air resistance in that joule means gamma is 0. Right, m would be weight over gravity, which is 2 over 32, which is 1 over 16. Our k would be the force over the extension, which is 2 pounds over 1/2, which is 4. And so we end up with 1/16 u double prime plus 4u equals 0. With these initial conditions. Did you get up to that point?
Where was I? Yeah, I got to that.
Oh, so you had a problem with something after this?
Yeah, so that, I didn't realize it was actually an initial value because you have the velocity, the upward velocity given and then.
Right, that's this.
Yeah.
It says velocity 1 feet per second upwards, right?
Okay.
Upwards are negative.
I think yeah.
So you guys will be able to finish. It's right, it's just a homogeneous thing, so you do your initial, your characteristic equation, solve for the r, and then it's going to be a complex root, and so you're going to have like c1 e to the, well, it's not going to be e's. R is just going to be minus 4 times 16, and then you take the square root of that, plus or minus. So you only have the sines and cosines. There will be no exponential part to this.
There was one of the problems where actually there was no complex root, it was only e.
Yeah.
That makes sense.
For a spring problem,
Yeah.
that
There was no cosine and sine, it was just e to the negative.
it's not realistic, no. But I don't know if it's something they throw out. Any questions? Yes.
Question for question 1+6 happy relative asking for when does the mass first return to the position?
Equilibrium position is when position is 0. So the mass is oscillating, so it'll probably pass 0 several times. They're asking when is the first time it comes back to 0.
So asking for the
Right, so basically you're going to set u equals 0 and solve for t. And the smallest positive t is the one you're looking for that one. Right, so they say, when does it first return to the equilibrium position? Equilibrium position is position 0. Just find when it hits position 0. And the first time would just be the smallest t value. Because they said the first time. Right. The questions?
For problems that you use undetermined coefficients, is it possible to also use the variation?
Yes. Variation of parameters is a general method. You can use it anytime.
Which method is more efficient?
Well, in general, undetermined coefficients, if you have that nice form, use variation of parameters otherwise. That's the standard practice. This thing with variation of parameters, you have that issue of the integrals can get really ugly. So you sort of, to avoid integration, you use undetermined coefficients unless you can't. So yeah. So remember, Wednesday, you have to get above an 80 to drop a test. So make sure you study and you can do well. I think